Oh, thank you very much. My name is Gary Wong. I'm a research associate in the Flux Research Group at the University of Utah. And recently, a lot of my job has been helping to establish a new wireless testbed called Powder. So I apologize that some of this talk will seem like it's kind of out of order because there are a lot of parts that we want to start in the background that will take a while to complete for a live demo. So I'm going to be kind of starting things and then without much explanation of what it is, and then while it's running, I'll describe what's going on. So apologies for the forward references, but I hope that things will become clear by the end. So you're welcome to participate in a sort of hands-on walkthrough of the system if you would like to. If you want to follow along, you'll just need a laptop and a browser. And most importantly, you will need to sign up for an account. So if you, could you please raise your hand if you've successfully got an account on Powder using the URL that was announced earlier? Any? Okay, so at least some. If you would like to participate and you don't have an account yet, please open up powderwireless.net/GRCon in a browser. Fill in the screen that will show up there, and somebody back in Utah will approve you. It'll probably take a few minutes, but hopefully it will be fast enough that you will be able to follow along. So I'd mentioned the Powder testbed. Powder is one of the Power, P-A-W-R, platforms. Power is a nationwide NSF project. It's a large project, a $100 million scale across all of the test beds. It's a joint government and industry collaboration with about half of the funding federal government via the NSF, and the other half contributions from industry. There are 28 companies and trade associations contributing equipment and other resources. Power will ultimately include 4 city-scale wireless test beds, of which Powder is one set up in Salt Lake City. So far, 2 projects are active, Powder Renew in Salt Lake City, and there is also a New York City based project which has been awarded. And the other 2 test beds haven't yet been chosen. The round 2 request for proposals is out. It might be starting to get too late to complete a detailed proposal now, but perhaps there's still some window. So the overall Power Projects for Advanced Wireless Research program is described at advancedwireless.org. As I mentioned, Powder is our platform. It's in partnership with the Renew team from Rice University. And the sort of emphasis of our testbed is on providing deeply programmable, so end-to-end software-defined infrastructure. So our radios are, for practical purposes, all software-defined radios, and we're going to be deploying them over a portion of Salt Lake City, starting on the University of Utah campus in the first year, and then expanding to downtown Salt Lake City in the next 2 years following that. The scale is that we'll have 18 base station sites. These will primarily be operating USRPs supplied by the NI and including ETIS Research industry partners. So the base stations, we're planning to deploy multiple N310s at each of those 18 sites. We're also going to add dozens of mobile nodes. These will be partly portable radios set up as kind of backpacks, and others installed in shuttle buses on campus and other city and maintenance vehicles. Those will be smaller, less powerful. They're likely to be small form factor PCs with USRP B210s. And then the wired infrastructure, we have some existing compute clusters that we're going to expand at 3 sites, two on the university campus and 1 downtown. And we're also adding massive MIMO hardware. This is supplied through Skylark Wireless, and who have extensive collaboration with the GNU Rice University team. So you can learn more about the Powder portion of Power at powderwireless.net. I'm afraid that Powder is actually an acronym. It stands for Platform for Open Wireless Data-Driven Experimental Research, and I apologize for that. It was not my name. So has anybody subsequently gotten an account approved? How many in total now, either since the beginning? Okay, so for anybody who has got an account, please log into powderwireless.net. I'll be doing the same thing on the projector, so everybody will be able to see whether you're just following this one or running it yourself on your laptop. So log into powderwireless.net, and after you get through the login page, you should see something a little bit like this. Regardless, the toolbar should be the same, whichever page you're on. So after you're logged in, if you have the instruction sheet, I've put out some handouts on the tables. Now if you follow along on step 3, this is how to start an experiment on Powder. And again, I'll come back and explain while things start. We want to get this done as early as possible because it takes about 10 minutes to get through it. So please choose Start Experiment here if you're following along, and the network is slow, but should get a page in a few seconds. Hopefully it's running faster for you than for me. And it'll pop up with the page and the Change Profile button here, down in the bottom right corner of this pane. Please choose GRCon18. You might want to use the search box if you're getting extraneous profiles first. I'll explain what a profile is later, but GRCon18 is the one we want. Select profile, then next, go quickly through the next couple of tabs, and then experiment duration 1 hour will be more than adequate, and finish. So this will say, please wait for the next 5 or 10 minutes. Now let me swap back and explain what's more details of Powder and what's going on with that experiment. So here's a map of the deployment. I described earlier the fixed base station sites are the little snowflake symbols here and here. The red area is the University of Utah campus. That will be deployed first. And then later on, this is a suburban area where shuttles connect between campus and downtown. And the purple is the downtown areas with high buildings, obstructions, multipath, and so on. So there should be a variety of RF environments. These 3 blue circles are the compute cluster backbones, and then there's a 100 gigabit backbone fiber link connecting the clusters, and then each of the fixed sites each have a link to one of those 3 compute clusters. We've been running some simulations of RF propagation through the proposed sites, and since this was run, we've also been on the campus sites at least, we've been taking up USRPs and antennas up to the rooftops of the buildings we're hoping to use, and driving around the shuttle routes and verifying that the predictions are plausible enough to select these sites. So far, we don't have any outdoor deployments that are active yet, but we do have what we call our technology preview. We've got some USRPs wired up through an attenuator matrix in the lab, and that's live now. That's our instructions for accessing them on the sheet, and you can run experiments on real USRPs right now remotely. So if you had your appetite whet by some of the earlier talks, some of the cool things people are doing, and perhaps lack adequate hardware to replicate those results, maybe this testbed will be useful for you already, even without the outdoor deployment, which will be coming later this year. So to actually use Powder for research and experimentation, it's important to understand that all operation on the testbed is conducted under the context of what we call profiles and experiments. And profiles, they're kind of like templates for resources that the testbed can provide. So they include not only hardware resources like servers, radios, wired links, and we actually will extend that to wireless links as well, but also software resources. So a profile might refer to a disk image, for instance, containing software that the testbed will automatically bring up for you. And the profile that I mentioned earlier, the GRCon18, that one includes GNU radio. So you can get a dedicated PC with GNU radio pre-installed in 5 or 10 minutes. And then an experiment is what you get once you instantiate a profile. It'll be, rather than an abstract description of the resources, it will be an actual dedicated and provisioned, so it'll be, for instance, not a generic description of a PC, but it'll actually say, you know, you've been allocated PC 1, 2, 3 within this cluster, and accounts will be set up for you, disk images loaded, that kind of thing. So profiles can be programmatic or static. You can write a Python script that will generate a description of the resources, or you can pre-configure a static set of resources and then instantiate that. So let me swap back to okay, so it's still going, hopefully nearly there. Once that tab gets to the end in this graphical view of the network topology, which is trivial in this case, just a single node. Once the icon turns green, that will have provisioned the experiment, and we'll log in and run GNU Radio Companion. Is anybody successfully up to the same stage following along here, or run into errors before this step? Anybody raise your hand if things are looking the same, please? No, okay, so, and how about anybody trying to follow but something's gone wrong? Okay, so some successful, some not. Sorry, I don't really have time live to debug, but I'll be happy to come and talk after the session and look in more detail. So actually, let me swap the order a bit. This pre-canned demo, to support multiple people running it at once, I'd run just a pure simulation, so GNU Radio Companion with a flow graph without any hardware source and sync blocks. But we do have a small number of real radios, like I mentioned. So here's one I've preloaded that will that's running on 2 different systems. These different tabs are actually different computers, just looking identical right now. So let me show you what a 2 flow graphs on communicating radios would be like. So if I run GNU Radio Companion on a receiver node here, then here's a trivial QPSK demodulator. So by instantiating the profile, this is the one described in step 8 on the handout. The testbed has automatically found 2 compute nodes with USRP B210s connected over USB. It's automatically configured the RF link between them through the RF attenuator matrix in our lab, so that the 2 machines chosen will communicate over RF. So that's the kind of task that the testbed performs for you remotely and automatically. So here's a receiver getting nothing. There's a little bit of a DC offset, but otherwise there's no transmitter running yet. And if I come over here, run a counterpart transmitter, and it'll pop up a corresponding flow graph with a random source fed into a QPSK modulator, and then feeding both a GUI and the USRP, which has the RF link to the other computer. So if I run this one, you'll see it's going to load the firmware because the machine is rebooted and started during the provisioning step. So we'll see the GUI come up immediately, and then in the background, down here, we should see the USRP eventually come up. And so here you can see random data over a QPSK constellation. So you see four clusters, and there's a bit of a noise source. Did I put noise in this? I forget how I configured the flow graph, but you can see the transitions between the 4 PSK symbols. So if that's actually live now, okay, so back on the receiver window now, we can clearly see the signal that wasn't there before, and then in the middle of the waterfall display, here's the transmitter coming through, and a little bit of lag on the VNC. And here you can see this, you might have noticed I put in the GUI on the receiver with this out of the demodulator. So you'll notice that the constellation display looks quite different between the transmitter and the receiver. I really enjoyed the talk earlier. Why does my signal not look like the textbook that Matt Edis gave? I think this is another example of something you might not necessarily, if you're not paying attention to what you're doing, this might be surprising. Of course, it's obvious there's no phase lock between the transmit and receive clocks. We've got 2 completely different radios, so the frequencies are slightly different, and without phase lock, the constellation is rotating at the rate of the frequency offset between the transmitter and receiver. And obvious if you stop to think about it, but that's a kind of thing that crops up. This is not like the textbook because of real-world conditions that you might not always account for when you're thinking at a higher level of abstraction. So that's the kind of thing that I think shows the benefit to running on a real platform where you can operate real radios. If you operate on the over-the-air ones outside, experience real-world conditions which you might not easily be able to recreate or simulate in the lab. So how's the experiments going now on anybody trying? Okay, my node is ready. So is anybody else up to this step? Okay, so depending how hungry you are or how eager you are to get to lunch and turn off your computer, you'll be able to follow on the steps on the sheet after the session. The next step would be to click on the node, get a shell here, and then the command on the sheet. There's a shell script to start the VNC in the browser set up to be able to follow along the graphically. So run vnc.sh, make a password, and in a couple of seconds it will pop up a link which is clickable in this funky shell in the browser thing. Click that, and then annoying certificate errors. It's just because it's using a self-signed certificate because it's a self-generated instance of Apache. Okay, then type in the same password, and then now we can run GNU Radio with a simulated connection. So this is what you should expect to see if everything goes well, following along the instructions on the handout. And then if you skip ahead to step 8 and 9, that's the version I showed you earlier with the real hardware. This is the simulated one if you're curious to see that. So you're probably familiar running GNU Radio Companion on your own hardware. This is just doing it one state over. And without needing to own the computer that is actually running things. So that's as much as I have. Are there any questions on Powder or using the testbed?
We have time for one question, or maybe two.
Hi there. Really interesting. Is there any thought of eventually being able to just have users around the world create nodes and be able to join the network?
You mean with their own hardware outside Salt Lake City? All of our gear that we've planned is UHF and up, so it's not really practical for the vast majority of our deployed hardware. By coincidence, the building I work in has a decommissioned amateur station with a nice multi-band Yagi HF, and of course the USRPs are perfectly capable, well, with the right daughter boards are perfectly capable of working HF. And there are other sites, other SDR sites in Utah I'm really quite tempted to try and get HF capability in, which would really make worldwide links like that more plausible. So on a personal level, yes. On an official level, no. There's not quite any plans. If you go to, I think it's utahsdr.org, if I have the URL right, is receive only. Yeah, there we go. There's WebSDR. Set up there in northwest of the Great Salt Lake is a nice RF quiet environment with a low noise floor, and it's receive only. And I'm hoping to get transmit capability in our testbed, which would kind of be a good counterpart. We're downtown in a noisy environment, and that's nearby in a quiet one. So
Give a round of applause.